whatever it is that we're working with. 2-3 starts to transition into doing something. Has anybody taken the SAT? Anybody? No? You have? Do you remember you got your results back? Do you remember what the grades were given to you as? Were they just given to you as a number? But no percentiles. I think it's the ACT, or is it the, I can't remember
Well, I
which.
did the PSAT and I got a percentile.
PSAT, okay. Percentiles. Have you guys ever heard of percentiles? You have, because you just told me. As for the service, for military? Yeah. I almost took that. I almost went to the airport. Okay. Anybody who's heard of percentiles, do you feel like you know anything about them, like what they represent?
Doesn't it just represent like where you fall? Like,
Sure.
kind of.
Yes, it does. It's very surface level. But if I said I was in the 71st percentile, that's a bit more specific, right? What does that mean?
Like you're above 71% of the population.
Of everybody else. I like it. Which is why, for a lot of standardized tests, like the SAT, which I thought they used to, but maybe I'm thinking about something else, that they gave it as percentiles. Because what happens with the SAT? Do they give the same test every time? I mean, imagine that. Holy crap. Somebody with a photographic memory could make a lot of money. So they change it every time. Couldn't they arbitrarily just change it to make it harder? Not like they did it on purpose, but couldn't that happen randomly? They changed some questions and it became a little bit harder. Wouldn't it be evil then to measure just by pure amount of things you got right if the test you take is harder than the one somebody else took? Yes? Does that make any sense? So the idea of percentile, if I was in the 71st percentile, do you know, on a test, let's say, do you know if I passed or failed?
Passed.
The only thing you know is that I scored better than 71% of everybody else. You guys with me? That is exact. Now listen, this is a huge note to take. Let's see who follows my advice. What does a percentile always mean? Right? Whatever percentile is, that percent is below that value. Right? Whatever percentile I give you. So for example, if you were in the 80th percentile, which we will represent, because math people don't like to write, we will represent like that. 80th percentile, P80. It's not a new exercise phrase. It's just 80th percentile. That means that that value, let's say that is a 90, right? That means that 80% of all students who took that test scored below a 90. So in general, when I say this was in the 80th percentile or the 20th percentile, that is the percentage that got below that. So is it always bad to have a low percentile?
No.
No, it's not. Good. If I'm playing golf, do you guys know how golf works?
Low score wins.
Lower score is better, because the score is how many shots it took to get into the hole, or putts, or whatever the hell you call it.
Wait, you're saying the 90 is, what is the 90 meaning?
That's my grade on the test. So if this is a test, and I was in the 80th percentile, but I got a 90 on the test. So I really want to make this distinction. The percentile by itself doesn't have shit to do with your grade. Can you imagine a class where everybody failed the test? That would mean the 100th percentile failed, right? The highest score failed. Okay, I like it. Which was my first grad school class. I got my test back, and I got a 21 out of 48 or something crazy, whatever the hell it was. And my teacher said to me, "Good job, Jeff." And I was like, is he being a dick or what's going on? And then that's grad school for you. They curve the grades and shit, so I didn't think a lot of it. But you can imagine, there has been colleagues of mine that unfortunately kind of bragged about the fact that they had everybody failing their studies. But so the score of 90 80% of the students that took this test scored below a 90. You guys with me? So if I just tell you, I got in the 71st percentile in this other class, do you know if I passed or failed? You don't have a clue. I could have made it 98 because everybody scored like 98, 99, 100. Does that make some sense? Okay, I like it. But it does make it better then to compare things that are not completely different, but that are different, right? So if you made a 60 in your history class and your friend made an 80 in their composition class, and like I scored better than you, is that necessarily true?
No.
All right. Because your percentile might be better, right? And then hopefully your teacher will curve the grades if that's kind of true. I don't know if you guys are still with me. Let's get a little more specific instead of all these vague examples. Let's talk more about 80th percentile, for example. So let me make up some numbers, which is half of what I do. Here we go. Notice something about these numbers. Can you already tell something very important about these numbers?
They're from least to greatest.
Yeah, they're sorted. Yes. What are you going to do, Jeff? Look at you keep going. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Let's make it a nice 10. Is that a big sample? No. Which will lead to some weird things, so we just got to understand that. It's a small sample. There's not a lot of data points. But it's pretty good for getting a feel for what to do with this shit. How would I figure out what P80 is? Can somebody give me a guess for what that is? See if you guys understand what we were talking about earlier. It's definitely not 14, right?
Would you find the average?
Is it 41?
See again?
Is it 41?
Okay, I gotta guess. So let's put my guesses down here. 41. I gotta guess. Anybody have a different guess? Or does everybody think that's true? Because somebody said something, so let's go with it. Anybody have a different idea? Anybody notice my puberty? Okay. Why did you say 41?
Well, I thought that you said that it's everything below, I guess the 8th number is 59.
I'm not saying you're wrong, and I'm also not saying you're right. You don't know how to do this yet, so this is just, do you have a feel for what it should be?
Yeah, my idea.
41 is, why did you say it? Just tell me.
Well, I was like, okay, so the 8th percentile is 10 of them, it has to be the 8th number.
Okay,
It has to
stop
be
right
the
there.
8th number.
I like it. So this is the 8th number.
Is it?
It's not the answer. Don't worry. How many numbers are below that one, though?
7.
7. So that feels like it's more like the 70th percentile, possibly, right? Do you guys understand? What's percentile supposed to mean? That percentage is supposed to be below that data point. Sue has a different idea. All right, 59. All right, so how many data points are below that one? There's 8 data points below. So that's 8 out of 10, 80%. Yay, Jeff, that looks good. How many data points are above it?
1.
Shit, what percentage is supposed to be above the 80th percentile, of course?
20.
20%. Now please stay with me. It's okay, it's gonna be okay. So what the hell's the answer then, Jeff? It's not this one, because it doesn't have enough below, and it's not that one, because it doesn't have enough above. So where should the answer be? Between those, kick ass. Sorry. Okay, I like it. Does that make any sense? Let me ask you this real quick. If I had 5 numbers, let me do this without flicking you guys off. Sort of gave away an answer there. Where would the 50th percentile be? It's got to be right in the middle. That makes sense, right? But what is 50% of 5? 2.5, right? But it's actually supposed to be the third one. Are you with me?
Yeah.
At all? What if I had 4 numbers? What's half of 4? 2. Is that the middle number?
No.
No, it should be the one between those two, right? Okay, so we have to connect the idea, what we know it should mean, with the math that gets us to it. So I know if I have 4 numbers, it makes sense that the answer should be between those 2. Correct? If I have an even number of numbers, is there a middle number for the 50th percentile? Is there a middle number from 4 numbers? Is there a middle number?
No.
No. So what's the middle? The one that's in the middle of the 2 in the middle is the freaking middle. Is there a middle number here?
Yeah.
Yes, it's this one. Oh, sorry. That's the middle number. So the third one should be the 50th percentile. But what's 50% of 5? It's 2.5. Oh, shit. So we need the math to connect in a systematic way with the idea. So we already kind of know, for 50th percentile specifically, we know what the answer should be. Right? And I'm trying to show you, wasn't there a situation where it was between 2? So there's a situation where it's also between 2. So what number is right in the middle of those? 50. Kick ass. 9 up, 9 down. Right? How many numbers are below 50? No. How many numbers are below 50? 1, 2, 3, 8. 80%, right? 8 out of 10. How many are above 50? 2. 2 out of 10, 20%. I like it. So I like the guess. 8th number made sense because 80% of 10 is 8. But it couldn't be that number because it didn't really work. It only had 7 below. It's supposed to have 80% below it. Okay, I like it. Maybe. All right. So P80 will actually be the average of 41 and 59. You do this long ass thing, or you just think about it. All right, so let's try to get some math involved here. Your step was a good first step, because the answer should be somewhere about 80% of the way in. So finding percentiles involves 2 steps. Right? There's 2 steps to find percentiles. The first step, so let's talk about the math that we're going to have to do. So P80. The first step is, where is the answer? And the second step is, go get the answer. Your first step for any percentile is 80% of how long the list is. Doesn't that just make sense? The answer should be about 80% of the way into the list. 80% of the length of the list. Okay? But then that's not the answer though, Jeff. What's 80% of 10? 8. Here's the thing. So now we're going to connect our math to make sense with what we know the answer should be. Anytime you do this first step and it comes out to be a whole number like 8, that means take the 8th and the next one, the 9th, and average them. So if I would have gotten a 4, I would have averaged the 4th and the 5th. If I would have gotten a 2, I would have averaged the 2nd and the 3rd. Anytime you get a whole number, after doing this, you average the 8th and the 9th. So that tells you where the answer is. Then I go do it, and of course we already did the work. But blah, 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 blah. Okay. So now a natural good next question would be, what the hell do I do if it's not a whole number, Jeff? All right. So thank God there's only 2 possibilities. Either it's a whole number and you do this, or it's not a whole number and you do what I'm about to tell you. What do we do? Let's see if you guys, so let's see if this makes sense. P50, if I have 4 numbers, half of 4 is 2, which means I take the average of the second and third. And that's exactly what we said earlier, isn't it? You guys with me? So far that's connecting with what we know is supposed to happen. What's half of 5? But the answer should be the third number, correct? So it seems like if I do this first step, so let's do another one. Let's use a different color, Jeff. Aw, it's neat. What if I did P, what do you got? P13. I like it. What's the first step? Same, yeah, this is the same problem. Same numbers, yeah. First step. Of? Good. And real quick, why is this 10? I really want to highlight. Why is that 10?
Because there's 10 numbers.
Because there's 10 numbers. Will you always have 10 numbers?
No.
No. I always have at least 1 or 3 people that will just do 10 every problem after I do this example. I'm like, shit, right? It's 10 because this had 10. If your numbers have 27 numbers in them, then you have to do percent of 27. I like it. So what is 13% of 10? Oh yeah, go ahead. What is 13% of 10? Sorry. What is 13% as a decimal? 0.13. And you multiply anything by 10, what happens to the decimal? It moves over 1.3. Is that a whole number? No. So if it's a whole number, I average that one with the next one. If it's anything else, I round up and take that number. So I'm not gonna like round, I'm gonna force it up. So the answer is the second number, and the second number is 14. Now, very quickly, here's where I want to point out some weirdness with the fact that it's a small sample. Can somebody tell me without doing any work what P12 would be?
Also 14.
Also 14, because you get 1.2, round up to 2. What about P11? Also 14. Why is that okay? It's a small frickin' sample, right? There's only so many data points that could be these things. So to be really honest, percentiles really only make full sense if I have a kind of a larger sample. Yeah.
Wouldn't you, because in the P80, didn't you take the 8th and the 9th average? Would you still take the 2nd and the 3rd average
No.
and do all of that?
I got a whole number. That's why I did this.
Okay.
I did not get a whole number. Round it up, take that number. So as a person doing a problem, you kind of hope for a decimal because then there's less work.
Okay.
Because when you round up, you take it, you're done. Yay. You get a whole number, you're like, ah, shit, I gotta average these two. Maybe. Not at all. No. It's kind of related to why we don't round down for the class width. I want to make sure that I actually have at least that percent below it. And again, I don't want to get too technical, but with a small sample, a lot of this doesn't quite make good sense because there's only so many data points. In a larger sample, everything's great. The book has a different method to do percentiles that is wonky as shit. For small samples, it doesn't matter because nothing's really jiving with small. With a big sample, my way is the same as their way. And my way is the way that calculators do it and everything else, so I don't know where they deal with theirs. Okay, now. Let's do one more example with a different number than 10. I'm gonna erase this, you guys ready? All right, let's see. Let's see. 11, 29, 38, 37. We're gonna do a lot of shit with this set of data. One, two, three. Let's do 14 data points. Watching Jeff make up numbers. So I'm going to ask you some specific questions. Can you find P25? Now be really careful. Why is it? What have I done that's really nice? Again?
It's more than
It's in order. So if you get a bunch of numbers that's not in order, you better do it first. Otherwise, you can make it be whatever you want to be. Let me just put that there, and now it's this. Ha ha. No. It's got to be in order to make it make any sense. Yeah. Well, let's see. What's your first step? You did.
I multiplied 0.25 times 20, I got 3.5, which is the decimal on the unit, and I found that the fourth number was 47.
I love it. Why do I? All right. 47. B25 is 47. Sweet. Did anybody else get that? Anybody else not get that? Did anybody else do it? It's got to be one of those two things. You all got together and was like, don't give them anything. All right. What's something else I can call P25? If I was 25% of the way through a basketball game, yeah, I could call it the first quarter, Q1. So another name for P25 is Q1. So let's figure out what Q2 is.
50.
P50, good. Now when you do half of 14, you get 7, which means you have to take
The 7th and 8th.
7th and 8th and average them. Oh, this is so, 4, 5, 6, 7, 8. Oh, that's nice. So what's P50? What's P50? What's Q2? What's this P50? Yeah, because it was 52, so it's 51. Oh, thank you, numbers. This is it's not too bad, right? No? I can't. You're the class I have the hardest time reading. Can't even tell from the eyes. Your eyes are just like.
Just to double check, you did 50 plus 52 divided by 2 to get 51.
Yes.
Okay.
I'm just looking at you like a lot of people look at me. Yeah, 50 plus 52 divided by 2, or you just realize 51 is between 50 and 52. It's beautiful. Okay.
I got head to the ER.
Oh, okay.
Yeah, heart isn't going so well.
Uh-oh.
Yeah.
Did you go to the nurse just then, or
No, I just got off the phone with the 911. So
you gonna be okay? I mean, to
So-
get there.
I'm getting a pickup.
Yeah, go ahead. That would make me feel better, at least. Yeah. Okay. You were just on the phone with the ER?
Yeah, so.
Okay. All right. So how about, what do you think I'm gonna ask you to do next? Q3. Now real quick, let me show you a shortcut. I'm pretty sure you caught on to this. No, what's up? What's up? No. This is important. If you have a question, at least 5 other people have the same question.
I just don't get it. Like, I don't.
All right. The 25th percentile has to have 25% of the stuff below it. Is that cool? So if you're in the 25th percentile in a test, that kind of sucks because only 25% of the people scored below you. If the number that is the answer has to have 25% of the numbers below it, right? Doesn't it make sense that to find P25, I want to go 25% of the way in to the list? If I go 25% of the way into the list, I'm passing 25% of the stuff. Okay, so that's why the first step is 25% of the list. And then we talked earlier about why it makes sense to do this, but if I get a decimal, I round that up and I take that number. So I got 3.5, rounded to the fourth. What's the fourth number? 1, 2, 3, 4, 47. That's it. If you do this step halfway and you get a whole number, you average that one with the next. That matches up with this idea, right? Yeah. That's it. So often, you feel like you completely misunderstand when there's one little thing somewhere you missed that makes everything not make sense. If I just say that one little thing, you're good. So don't sit on a question. I'm not coming down on you. Trust me. Anybody else? Immediately ask, right? Don't feel like you're the only one. Yeah.
For the staffing. So how do you get 51 again?
Oh yeah. All right. Are you cool with this?
Obviously, when 50, but
Yeah, so the 7th and 8th, 50 and 52. And of course, if you do that, you get 51. And of course, averaging two numbers is also just finding the number that's in between those two numbers. So if it's easy to see what's between them, that is the average. That's awesome, yeah. Okay, now, yes?
Just really quick, so when you say like the 80th percentile, like the example you gave, and you scored a 90 on the test, that means that the 80th percentile, meaning 80 and above, scored 90 and above?
Yeah, so 20%. So if I made a 90,
Yeah.
I'm the 80th percentile. 80% of everybody made below a 90, 20% of all the other students made above a 90.
Okay.
Done. That's what it always means. For a smaller sample, it doesn't quite work as well because there's only so many data points. So always keep that in mind when you're working with a small sample. Okay. Larger sample is perfect. So let me see if I can push this a little bit. Let me just tell you this. See if you guys get this. You can do the same damn thing for this, or you can realize I had to go 4 in from the bottom, from the beginning to get to the 25th percentile. So I go 4 in from the end to get to the 75th percentile. Does that make any sense?
Yeah.
4 in from the bottom is the 25th, 4 in from the top is the 75th. So they go 1, 2, 3, 4, 93. Done. Now if you do the steps, what's 75% of 14?
10.5.
Rounded to 11, the 11th number. Oh, yeah, about to say that's 11. Okay. Right? Maybe. And again, you never have to do the little shortcut I did. If you never want to, you can just do it the same way. All right. Now, obviously, I've done this on purpose, right? There's Q1, Q2, Q3. Right? And again, I'm always worried about my students that don't, well, it doesn't. You don't have to have ever seen a basketball game or a football game, but it's kind of nice to kind of have this analogy. I want the beginning of the game, the first quarter, the second quarter, the third quarter, and the end. We call that, because we're math people and we're really creative, we call that the 5-number summary. Because there's 5 numbers that summarize my data, right? So the 5-number summary, holy shit, there you go, Jeff. I just forgot how to spell number, that's all. Nothing to worry about. Is the lowest data point, Q1, Q2, Q3, and the highest data point. Beginning of the game, first quarter, second quarter, third quarter, end of the game, right? So what's the lowest point? 11. Q1 was 47, Q2, 51, Q3 was 93, and the highest data point was this show-off person, 101. Okay. Now, there's one. You guys remember stem and leaf? Remember that? Stem and leaf plots? It was a kind of an interesting name. The one we're about to make is called a box and whisker plot. Why not? Right? So I think the book just calls it box plots because they're boring. It's box and whisker, which is really exciting. Right? So here's how this works. I'm going to erase this. Is everybody ready for that? Yes? Okay. One of the most important things when making any graph of anything is to have a consistent scale. Somebody tell me what's wrong. Do not write this if I do this. Is there anything wrong with my scale, or does that look good? My scale sucks bad. I mean, how far is this? How far is this? 4. How far is this? 42. Holy crap. I am lying to everybody. I've made this distance different depending on where you're looking. That is lying. Okay, so basically I'm going to do this, but the right way. I want the data to have a place to go. So let's start at 10. Start below it. Let's start at 10, because then it can make a scale that's kind of easy. I want to get up to 100 and something. So somebody have an idea of a step size I should take? How long, how big each step should be? Yes?
Oh, I didn't even know my name was up.
Oh.
Maybe by,
Your subconscious is like, I'm gonna make her ask a question.
I didn't even, I have like put my name right there. Maybe by 10s?
10 might work. Does that sound good?
Yeah.
Everybody else is like, somebody said something, okay. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, that's pretty good. All right. Okay, and then, now here's what we do. Don't draw any circles or any shit. This is a box and whisker plot. There's going to be a box, and it's going to be frickin' whiskers. There's a reason it's called this. Put a line above each data point we got. So 11, 47, 51, 93, 101. Okay, that is weird. It's weird, Jeff. I don't see a box. False advertising. Then you do this. There's your box, and then you do this.
Oh, these.
Have you ever, yeah, you seen that before?
Yeah, briefly.
Has anybody else ever seen that before?
I've done that before.
Oh, you've done it before, okay.
It's on campus.
Yes, anywhere that you have data represented, this is very likely to show up somewhere. What does this mean? All right, can anyone tell me, and I apologize for the joke, but what's in the box? How much, what percentage is in here? What is in, what's in the box? If you don't get the reference, you're fine. It's no. What's this? What was this one? You guys remember? What was this is a little awesome. What was this one mean? What was that?
What's the third?
Low Q1, Q2, Q3. What percentage is below that? Q3, of course. What percentage is below Q3?
75.
75%. What percentage is below this Q1?
47.
No. What percentage is below Q1? 25. 75. 25. What's left in here?
50.
50, right? 75. Chop off 25, I'm left with 50. There's always 50% in every box. If you ever see a box plot somewhere in the wild, 50% of the people are in the box. And they're all screaming to be let out. Let's out. Sorry. So sometimes, has anybody ever looked at, are you looking at, anybody looking at like transferring to a 4-year sometime? Anybody? Have you analyzed different colleges at all? There's a book called, there's a Princeton Review of Colleges. And they'll tell you the middle 50% of SATs, the middle 50% of GPAs. So they kind of chop off, this is the heartland, and they chop off the under and overachievers. Just to give you an idea, here's the heartland, the heartland. Here's the middle chunk of our students. This is our like average student body is in here somewhere, right? And then you have the under and the over. So you'll see middle 50% data if you're looking at comparing colleges. Yes?
So you only box in the 50%.
Yes, so that box automatically every time has 50% of the data in it.
Okay. And do you always want to make that 5-number summary when you do a box?
Yes, box plots are defined by the 5-number summary. Now, what do you think would it mean? What would happen? Let's say I have this. Let me just make up some shit real quick here. Sure. Not Q4, Jeff. Oh. Now, what's weird about this set of data? Two of the numbers are the same, which means, so let me do this. Sometimes you'll see exactly what I'm about to do. You have another one beneath that you can compare to. So this top one was one class of mine, and the bottom was another class. This person I'm concerned about. They spelled their name right, got 11 points. So 20, 30. So what happens here? So here's what happens. I have to do another line for 30, so I make this a dotted line. So that represents 2 lines overlapping. And then I do a line for 45, and then I do a line for 95. And I understand that me saying do a line is not quite what I want to say there, but I want. Now, where's the box? From what to what? It's got to be from Q1 to Q3, right? So you can always kind of double check that. So it's got to be from 30 to 45. But do you see how this just kind of moved over on top of that one? Do you see how that could happen if I have a lot of repeats in my data?
Yeah, so do you still draw the lines to the other?
Yes, definitely. I just haven't finished. So, yeah. That's the weird thing. Anything that overlaps something else, it would be a dotted line to show that it's overlapping.
And so for Q1, Q2, Q3, do we always make that like 25, 50, 75%?
That's what they mean, yeah. Q1 is the first quarter, which is 25%.
Oh,
Yeah.
Okay.
Cool. It's okay. But that's what we gave them. You're
I'm
fine.
happy we established that.
Yeah, okay. And now, which class, this class didn't have somebody score as low, did it?
No, I mean, it's still pretty bad, but.
Yeah, so which class did worse, do you think, on this test?
The bottom.
Yeah. Look at this little thing. Their box is tiny. What does that mean, do you think? 50% of the people scored between a 30 and a 45. As a teacher, how should I feel about that? Depressed is a good thing. I mean, it's a good answer, not a good thing.
Depends what class you're taking.
It's true. So, drawing these on top of each other with the same scale is a nice way to kind of make comparisons. Which one has more variation in their grades? Definitely. Aren't these grades a lot closer together? And in general, it's closer. It's not as wide as it. So this is a lot more spread out. There's more variation allowed up there. Okay. Maybe. Okay. So, I do have a handout, but I think I'm going to do it next time. I want to do mean, median, mode, and then I want to let us out early.
Yep.
Does anyone have a problem with that?
No, you should do it, for sure.
Especially now that I said it, if I didn't do it, there would be an uprising.
A riot.
There would be a riot, and I want to avoid that as much as I can. All right, so let's talk about, so this is measures of position. right? That's basically what somebody said in the first thing, is percentiles tell you where you are relative to everybody else, the measure of position. So what we're going to transition to is the measures of center, where the middle of the data is. Just like, I'm trying to keep in mind. Where's the clock? There it is, Jeff. Yeah, you're tired, man. Yes, okay. This is section, if I remember correctly, this is section 2.5. They did box plots and percentiles in 2 different sections, which is crazy. They go together. So percentiles and box plots was 2.3, 2.4. So we're getting into 2.5 now, and then we only have 2 sections left for chapter 2. So measures of center. There are multiple ways to get an idea of the middle of a set of data. We're going to see why here in a minute. The most obvious way, if I said find the middle of this data, what would you do? There's actually 2 answers to that on each set.
I would add them all together and divide it by 2.
And what do you call it?
The average.
Wait, divided by how many?
However many.
Good. Divided by how many there are. Okay, okay. I'm with you. So that one is what we call the average, but it's actually called the mean officially. Because the word average indicates more than one process. So the average that we colloquially, don't even try a word like that, John. Am I drinking? That we colloquially, screw it. The word average that we use all the time means the mean. Okay. Plus, it's got 4 letters and it starts with the letter M, so math people love it. So the mean is just the average, so it's easy. So here's our first equation. What did I tell you? You guys remember what I told you about statistics? Normally people, there's no word problems. I'm pretty sure I told you about this.
Yeah.
But there are Greek letters that you have to know what they mean, right? And there's concepts that are difficult. There's no algebra. So here's several Greek letters coming your way. First, let's say it in English. To find the mean, add them all up, and then divide by how many there are. Holy shit, what letter is that? I don't know. How many of the, yeah. Okay. So let's condense that. This is why math people don't like it. It's too many freaking words. So here's the symbol that we use to indicate that we need to add stuff up. What's the more formal word for add? 3 letters. Sum. I like it, right? So, since that's the letter S in that word, we decided to use the Greek letter S to make it look all neat. So the Greek letter S is sigma. I can't remember, I don't think I put it up on canvas yet, the Greek letters. I did? Yay! So again, you don't have to memorize them, dear God. I just put it there for you to reference. You don't have to look at it if you don't want to. I'm going to tell you what you got to worry about. This means add these up. It doesn't mean anything by itself then. It always needs something inside of it to make sense. This is like add what up? What do you get when you add up? What if I said that to you? Hey, what do you get when you add up? What do you say to me? Add the what up, Jeff? What the shit? Right? So this is saying that. Hey, what do you get when you add up? Well, shit. So what letter do I use to indicate all the data points at once? We know this from algebra. What letter do we use to represent a bunch of values?
X.
X. Kick ass. Add What is Add up all the data. So X is the main letter I use for data. I could have more than one list of data, then we use Y for the next list because we're really creative. And what letter do you think I'm going to use for the number of data points? The number. The N, yes. I don't know. Yeah, why not? Let's do that. Okay. So again, it's just, there's some letters we're used to, There's Greek letters of shit, but it's exactly like, if I ask you to do this, what's this? What's that? What is it? 5. Why were you able to do this so quickly? Because you internalize the meaning of the symbol. That's it. So when you learn a new symbol, you have to go through that process again. So when you see this, you think sum of these. Okay. So how in the world could I do this? What does somebody have to, of course, give me? Like we just said a minute ago, what do they have to give me? They have to give me data. Or else I got nothing to add up. Okay. So let's do an example of this in a minute. There are 2 different symbols for population mean and sample mean. Why not? Population is a Greek letter. This is a population, right? I think I pointed this one out. It's one of my favorite ones. It's the French cow. Mu. Mu. So it's a U with an extra leg. And everybody writes M, but try to make it a mu, right? It's like that. So some of you guys are like, that's an M. I'll leave it alone. Right. Sample, it's X with the bar on it. So we call that X bar. And this one again is mu. Neato.
Are you saying population is the mu?
Yes, so if I see that symbol, I know it's a population mean. If I see that symbol, I know it's a sample mean. I like it. Good, got it? Okay. Now, let's focus on this for a second. I don't know how early you guys think I meant when I said early, but probably not as early as I thought. Let's see. So what about my data look like this? I'm going to give it to you this way for a reason. All right. What if the data was this? What is the sum of x? Oh my gosh. Are you catching it? Yeah. Yes, everybody cool, right? Just add them up. Ooh, big hit. What the shit would this be? It is not 14 squared. Let me just take that off the table right now. That does not say, this would be 14 squared. You guys see that?
Yeah.
The difference? That is 14 squared. What the hell is that shit?
That's just squaring the value.
Good. Why was this easy? Because I have a list of x's. Do I have a list of x squares yet?
No.
Let me make them. This is exactly what you're going to have to do. You're going to have a lot of formulas that have this symbol in it. What do? You cover it and say, I need a bunch of those. I got them. I need a bunch of those. I don't got them. And then they go make them. Maybe? Because you can't add them up if you ain't got them yet. So let's make them. What's x squares?
4, 9, 16, 25.
And now I can do this.
Just not that fast. 58. No.
I think it's 54, is it?
I don't know.
Yeah, 54. You got close. It's good. I could be wrong, man.
No, you.
I'm tired.
It is okay.
Okay. Does that make sense? It's going to happen. So what if I wanted, one last one. What if I wanted this?
You have to make a separate list. No. I don't know.
Stop. Just sorry. No, careful. What you just said is this. Do you see the difference?
Yeah.
This is take 1 away from the sum, which would be 13, right? That's not what I'm asking. Cover this. What do I need a bunch of? I need a bunch of x minus 1, so your answer was right. What's x minus 1 for each row?
1, 2, 3.
Now that I got these, I can do what this wants me to do. Does that make sense? If you cover this, you go, oh, I need a bunch of those. The parentheses, so up here, if you cover this, you just need x's. I got those, easy. Here, oh shit, I need x minus 1s. I don't have x minus 1s. Bam, now I do. And now, of course, I get 10. All right, good, good, good. I like it.
Wait, can you get the sample part? Wait, is there anything different where the population and sample is? Do you see how it's?
No,
Wait, I'm confused on. Oh wait.
the formula is exactly the same.
You see where it says mu and then the bottom part.
X bar. It's exactly what you thought we would answer all calls. Right, is that what you're asking, X bar?
Above that?
X bar?
Yeah, yeah.
That's how you read this, X bar.
Okay.
That's X bar.
But you didn't give any examples of that one yet.
Well, I mean, to be honest, did I use mu or X bar over here?
No.
So it would depend, how would I know which symbol to use? Which symbol would I use? What would I have to know to know which symbol to use?
You'd have to know whether or not what you're calculating is.
Was this a population or was this a sample? If this was a population, I would say mu equals 14 divided by 4, I have to do it, right? If it was a sample, I would say X bar equals. I really want that understood. The work doesn't change. The letter you use to identify it changes based on if it's a sample or a population. So if I had a population, and I calculate the average, let's say I add them all up and I get 57, divided by 10, I get 5.7. It's a population, so I would say mu equals 5.7, because it's a population. If it was a sample, and I added them all up and I got 57, 5 point, I would say X bar equals 5 point. That's it. That's
Okay.
all. That's
But
it.
does that have to do with anything with population and sample those?
And again, the work, this was really just about this symbol. Did I actually calculate any average over here?
No.
All right, so if I told you this was a sample, and we calculated the average, what is that, Jen? What symbol would I use for it?
You would
The X bar.
use mu? Or wait. Yeah, no, yeah, sorry, X bar.
Yeah, X bar, that's it,
Okay.
that's it, that's all. The work doesn't change. Will the work always be the same? No. There are ideas that depend on if it's a population or a sample, and the work changes. As far as the mean cares, it doesn't care. It's like, no, I'm just add them all up and divide, that's what I am, that's what all it does. Okay, now, yes,
On this side you got 192.
which one?
192.
Oh, so what was the sum of x? 14, right? And then I did 14 times 14, and I think that's what it is. I did it in my head, and I got that, so I'm pretty sure that's what it is.
It's 196.
Yay, look at me go. But does that make sense? Because the inside's 14, yeah. Okay.
Gotcha.
All right, now. The next couple ideas are pretty quick. Why don't we just always use the mean? Has anybody ever seen a news story about home prices?
Unfortunately, yes.
Yes. They never use average home price or mean home price, ever. Or no. So let me ask you this. What if you were about to start at a company and there are 4 people there? There are 3 people that are working. I like the way I just realized I'm gonna say this. There are 3 people that are working, and then there's the boss. So, this is not true. All right. So this is their salaries in thousands of dollars. Are you guys with me?
Yeah.
So this guy's making 40,000, 42,000, 44,000, and the boss is making 600,000. If I went to this company, I talked to one of these people and I said, how much could I expect to make? And they tell me the average income. Is that an accurate estimate of how much I can expect to make?
No,
Hell no, why not?
because the 600 is an outlier.
Yes, it's an outlier. I like it. So we need another way to find middle, because that is not the middle. Why? Because the 600 is pulling it way up. Does that make sense? 600 is heavy. It's pulling the average towards it, like a gravitational thing. If, whatever the hell the average is. No. What is the average? But anybody can do that real quick for me? It's mu, because that's the whole population. Let's see, Jeff. Can you do it real quick? No, you can't. You suck. 120. 676. Divided by 4 is, what do you get?
181.5.
Well, 181.5, sounds about right. So about $181,500. So if they told me, oh yeah, $181,500, oh holy shit, I didn't even know. Right? All right. So that sucks. That's dumb. Same reason they don't talk about average or mean home price in La Jolla, for example. Or in San Diego, because La Jolla would, of course, in some other areas, would try. That's where I go walking and I say, oh, there's a house that looks really nice that I'll never even go inside. Hey. I just keep walking. Now, what is the middle number? That makes more sense.
43.
43. And we know this already as the what percentile? 50th, or the what quartile?
Second.
Second quartile. I love it. So that's P50. That is Q2. There's another Q. The official name for this now is the median, which makes sense because that's the middle of the road, right? The median is the number in the middle. It's basically P50. And the symbol for the median, it looks like a mean, it looks like an X bar that had a rough night. It's a little bar got crumpled. Right? No? Yes? Okay. So obviously if I have 4 numbers, the median is the average of the 2 in the middle. If I had 5 numbers, there is a median. So any odd set, I got a number that's the median. Any even set, I got to average the 2. Does that make sense? Okay. Okay. I like it. So anytime there's an outlier, median is better at giving you the center. And then the last thing, so we got mean, we got median, and we got, now those two, remember the keywords for data? The 2 types of data, keywords?
Qualitative and quantitative.
What do those 2 only work with?
Qualitative. Quantitative.
Quantitative, they have to be truly numerical. I can't average hair colors, right? So I need, but is my data always quantitative? No, I want one that works no matter what the data type is. And that's the one that says what occurs the most, because I could look around and say what hair color occurs the most. How is that a measure of center? Well, it's a measure of clustering. It measures how the data, is there a point where the data clusters? Which doesn't sound like the center, but it is a very loose interpretation of center, and it works for non-numerical data, which is kind of nice and inclusive. So, and it's called, does anyone know what it's called?
Mode.
Mode. I love it. So I always think about pie a la mode, pie with ice cream, and it's the one that most, because I want the most ice cream. Damn it. It doesn't have a symbol for a little dude, it's just a mode. So can somebody tell me, what's the mode for this set of data? Holy shit. Sorry. Mode is 2. What about this set of data? What's the mode?
There's mono.
Yeah, let me put one more number just to be safe, because this book is crazy. There's no mode. No number occurs the most, right? So there doesn't have to be a mode. Let me see, let me put this up here. What about this set of data? What do you got, Jen? Yes, it's bimodal. This book actually does include the idea of trimodal, which I think is crazy. And after that, we're like, okay, shit. If there's 4 places, it's not really a place that it's clustering. It's all over the place. And one more. What about this? Just to make sure. Just to make sure. There's a clear winner here, right? Yeah. So don't just list all the numbers that occur more than once. 15, 1, damn it. 15 is on top. Okay, I like it. Let's all go. I'm tired. Let me know if you have any questions. I think we need a little, leave it a little bit early. Yeah, it's not too bad, right? It's pretty good.